episode of Planet Hunters Coffee Chat. I'm your host, Kassie Prolongo. Joining me is my co-host, Nora Eisner. Hey, Nora.
Hi, Kassie.
Okay, so Nora, last time we had some really cool things that we were talking about. We were plotting some of the test data. You showed me how to beautify it to make it really cool and pretty, but there was actual reasons behind that of why you would want to do it. But today's episode, we want to talk about plotting it in multiple sectors. So I'm really looking forward to this. I can't wait to delve into it. I've got my Jupyter notebook all loaded. So let's get into it. What do I need to do to start doing this?
Fantastic. That's great that you already have it loaded. Let me share my screen. Cool, fantastic. So we're just going to start off kind of where we left off last time, and we just run those cells that we always run at the start, where we import those kind of important libraries, and we're just going to look at one of those sectors again. We're downloading the data, so we have the tick ID, we're looking at Spock data, and we're just going to do this for sector 23 for now. So this is what we were doing last time, and if some of this doesn't make any sense or you're not quite following, then maybe have another look at the videos where we discussed this earlier on, or the help sheets that we've also provided online. So I'm going to run this. So we're downloading the data as well in this cell. And we're just going to go ahead and plot that. So this is just one sector of data that we can see here for this nice target. But until now, we've only really looked at data from one sector, but often targets are observed in multiple test sectors. And that can just be because the TESS mission, as I mentioned in the very first video, kind of TESS looks at sectors of data and they rotate around every 27 days, kind of across the sky. But sometimes those sectors overlap and stars can appear in multiple sectors, in which case there is kind of multiple sectors of data. In addition to that, there's also TESS kind of has a 2-year rotation. So in the first year of the mission, it observed the southern hemisphere, then in the second year, the northern hemisphere, and then now in the third one, it's gone back to the southern hemisphere. So a lot of targets are being re-observed. And often we want to see all of the data that's available. So as Kassie mentioned, we're going to look at that today. So let's just start off by maybe looking at a different target. And I'm actually just going to go back to my favorite target, because
your
as
go-to.
I said, that's the only tick ID I know.
But it's your go-to, it's your favorite one. And one of these days, I want you to explain why it's your favorite one.
Oh, we'll have a whole episode on that.
Okay, good.
So I'm just defining this as tick 2, so just a different variable, and it's 555.255.72. And we'll press enter on that. And we're just going to check first what sectors are available. And we'll do that just like we did last time. Lightkurve, and then tick, and this time it's tick 2 because we've defined a new tick ID, and then author equals Spock because again we're only interested in that Spock data. We'll run that. But yeah, so we'll look at this example, and as you can see in this example, this target was observed in lots and lots of different sectors, and especially because my computer is running quite slow today, we won't look at all of them. So sometimes it's a convenience thing, especially in this example where we don't need to look at all the data. We will just look at a couple. So we'll actually, as you can see here, sorry, I should say that, this was observed in almost all of the sectors. You can see sectors 4 to sector 13. So that was the first year of operation. And then it went back in sector 27, which is when TESS returned back to the southern hemisphere in the 3rd year of the TESS mission. So yeah, so that's a kind of a lot of data there. So we're not going to look at all of them. So we're actually just going to take the first 4 of those sectors and we will just plot those. So we can define that by just doing select sectors equals available data all. And we're going to just take the first 4. So we're going to take from number 0 to number 4. Fantastic. So we'll take that and let's just, again, print that out. And you can see now we've selected sectors 4 to 8. So 0, kind of the 0th one to the 3rd one, which in Python is defined by 0 to 4. Okay, so we've now, just like we did last time, we've now selected targets. We've seen what sectors this target was observed in. And now we want to download the data. So previously, you might remember we had this command, which was just download and then open close brackets. But this time, because we have multiple sectors, we're going to use a slightly different command. So we'll do Lightkurve collection equals select.
Wrong one.
Sectors.
Yep.
And then this time we're going to do download, download underscore all, just to say that we have multiple sectors and we want to download all of the ones that we have selected, where these select sectors are these 4 that we have selected in this previous cell. And we always need to do these open close parentheses. Did I spell something? This is a good reminder that you need to spell things very accurately. I said sectors instead of sector.
I was just about to say this is a troubleshooting moment, and it's good to see these because it's not going to be perfect every time.
No, this happens all the time.
Mistakes.
Spelling's hard.
Yeah.
Luckily, Python usually tells you what the error is, so that's very helpful. So it's important to read those very carefully and to go back to the code and see what went wrong.
Right.
Okay, cool. So we have downloaded the data. So now we want to plot it. So let's do that. This is the same command that we always have. Collection.plot. I'm going to use some of those commands that we looked at in the last episode, where we looked at kind of how to enhance the plots and make them look prettier. So I'm going to say line width equals 0 and marker equals a simple point. And we will run that. Cool. All right, so we have this, we have now multiple sectors of data plotted. As you can see, it's kind of all over the place. All of the sector data, which you can see indicated by them kind of being on this different levels, they kind of have a different standard flux around which we have this fluctuation in the star. So that's not very useful yet. It's quite difficult to compare this data to see how the different data from the different sectors kind of correspond or kind of relate to one another. So what we want to do is we want to do something that's called normalizing it. And that simply means that we're bringing them to the same level and we want them all to fluctuate around the same value. And in our case, we will have them fluctuate around 1. And that just really makes it much, much easier to read. So that's normalizing is very important. In this case, we're going to normalize to 1, and we can do that within the Lightkurve function or the Lightkurve library. And we can do that with just 1 line of code, which I will write out now. So we'll do the Lightkurve collection, and we're going to just stitch them together. So at the moment we have kind of these all over the place, but we want to stitch them together and normalize them, and that's done with this function called .stitch. So we'll take that Lightkurve underscore collection, and we'll just do .stitch at the end there, and we will run that cell. Sorry?
When you say normalize, it's not actually, we don't put in normalize as a code function. It's just that's what's the name of this, how you're trying to put the data all together, basically.
Yeah, so when we have multiple sectors of data, this stitching together function does that normalization. But if we have 1 sector of data, we do need to use the normalization or a function that is called normalization. So we're going to start off with this one, but we'll get back to how we do this for 1 sector with that normalization command, which is a bit confusing. There are slightly different commands depending on whether you look at 1 sector of data or multiple sectors of data. But again, you don't need to remember all of these commands. These will all be available. They'll be in a kind of a cheat sheet.
Cool.
Yeah, so we don't need to remember them luckily.
Put that in the FAQs, please.
Yes.
Okay, cool. All right.
Cool. So let's plot this. We always like to visualize what we have done. So we'll take this, what we have just defined, the LC underscore collection underscore stitched. We'll do .plot, and again, we'll make it look slightly prettier. We'll use a marker, which again, we'll use a dot. And maybe we'll make it a different color. Maroon.
Ooh,
and
getting fancy.
It's a fancy color.
Yeah.
So cool. So we have this now, and I just think it looks so much better. We have it all on 1 line, all normalized around 1. So all those fluctuations are around 1, as opposed to these very high numbers that we can see back what we had before we normalized it. So this is very important to do this and to visualize the data and to analyze the data. It also just makes it easier to see the kind of the depth of transit events, if we do have transit events in here, and to see kind of how much scatter there is. It's much easier to see that when it's fluctuating around 1 than if it's fluctuating around these very large numbers that we have if we don't normalize the data. So yeah, as you've already said, that stitch function is only if you have multiple sectors of data. So it's kind of, the normalization is more of a side effect of stitching those together. But if we have just one sector of data, we often also want to normalize that. So we'll go back to that plot we had at the start. So we had this Lightkurve at the start, and you can see this is not normalized yet. This is fluctuating around very large numbers. But let's take that Lightkurve and normalize it. So we had previously defined this as LC. So we can actually just reuse that function. So we haven't redefined LC yet. So we can still use that and say LC.plot and have that there. So we can see that same Lightkurve that we have before, still not normalized. But now let's normalize it before we plot it, in which case we say LC.normalize, open close brackets, and then we can do .plot. We can do this all within one line and let that run. And there we go. We have that fluctuating around 1.
That's really cool. So this is a very silly question, but all of the data that you saw on Planet Hunters TESS, it's all normalized, right?
Yeah.
All of that data that all the citizen scientists go and start to look at, that's all normalized data.
Yeah, all that data is normalized. So that we actually normalize it around 0 instead of 1. It doesn't really matter. Yeah, it just fluctuates. So the fluctuations are just around 0 instead of around 1, but the idea is exactly the same. So the way that you get to this normalization, if you get it to 1, you just take the median value of that sector and you divide every single point by that median value, and that gets it down to 1. And if you want it to fluctuate around 0, you simply subtract 1 from everything.
Cool. That's great. Is there anything else that we wanted to talk about while you go through and plot multiple sectors and also normalize the data that we haven't addressed yet so far?
No, I think that covers that. Yeah, I think, this is a good way of plotting multiple sectors of data. This allows you to normalize it. And next time we will look at how we can bin the data, and we'll go over what that means and how we can do that with Lightkurve.
Perfect. Great. Nora, thank you so much. Can't wait to delve into the next one.
Thank you.
Thank you. Bye.
Bye.